Okay, so if you're in the AI world, you've definitely heard of Hugging Face. But let's be real. How do you actually use that giant library of models without getting totally lost? Well, that's what we're going to do today. We're going from zero to pro, and I'm going to show you how to find, use, and even troubleshoot some of the most powerful AI tools out there, all in just the next few minutes.
Think about it. You need a specialized AI for your project, right? Maybe something that gets French or can wade through legal docs. The old way? Building it from scratch. Ugh, that means tons of data, so much time, and a whole lot of money. It's kind of like trying to engineer and build a brand new car from the ground up just to drive to the grocery store. There's got to be a better way, right?
And of course, there is. This is where the Hugging Face Model Hub comes in. Just picture a massive public library, but instead of books on the shelves, it's packed with thousands of powerful, pre-trained AI models. They're just sitting there, ready for you to grab and use, like right now, for pretty much any task you can think of.
Okay, let's make this real. Let's say we need a model that can figure out a missing word in a French sentence. In the lingo, that's called a mask-filling task. So you hop onto the hub, do a quick search, and bam! You find the perfect candidate, camembert-base. And believe it or not, that simple little name is all you need to get the ball rolling.
All right, now for the part that feels like actual magic. You'd think that using a super sophisticated model like this would mean writing pages and pages of complicated code. Nope. With Hugging Face, it is shockingly simple. I'm talking you can get this thing up and running in just 2 lines of code.
Seriously, it's so easy, it almost feels like you found a cheat code for AI. Let's break down exactly how it works.
So it really just comes down to 2 simple steps. Step 1, you find the model identifier you want, in our case camembert-base. Step 2, you load it up using this amazing little tool called the pipeline function, and you just tell it what task you need it to do.
And just look at this. This right here is the magic. You import pipeline. Then, in a single line, you tell it the task, fill mask, and you point it to the model with that simple name, camembert-base. That's it. You're done. All the complicated stuff, like loading the model, getting the tokenizer, it's all handled for you, behind the scenes. The amount of power packed into that one little function is what makes all of this so incredibly accessible.
Okay, and this is a big but, this is exactly where a lot of beginners get stuck. That beautiful simplicity of the pipeline function can actually hide a really common, really frustrating trap. It's totally possible to have a great model, but use it in a way that just spits out complete and utter nonsense.
So, this begs the question. We know our camembert-based model is fantastic for filling in missing words, but what happens if we try to give that exact same model a totally different job? Like, what if we try to use it for text classification? To decide if a movie review is positive or negative.
And this shows the problem perfectly. Look on the left. We use it for fill mask, and we get perfectly good French words. Awesome! Works like a charm. Now look at the right. We try to jam it into a text classification pipeline, and the results are just random junk. It's not working. At all. So, what gives? What went wrong here?
Well, the problem is deep inside the model's architecture. You see, it has something called a head. That's the final part of the model that does the work. And this model's head was trained for one single job, filling in the blanks. Asking it to classify text is like asking an amazing pastry chef to rebuild your car's transmission. They're an expert, sure, but they have completely the wrong set of tools for that job. The results are just going to be meaningless.
So, this brings us to the pro way of doing things. There's a much better, more robust way to work that stops these kinds of errors from happening and, bonus, makes your code way more powerful and flexible. It's time to talk about the auto classes.
The auto classes? These things are a total game changer. The key phrase to remember is architecture agnostic. What does that mean? It means they're smart enough to automatically figure out the correct architecture for whatever model you throw at them. And that makes your code super adaptable. You can swap models in and out without having to rewrite a single thing.
Let's just look at a side-by-side. On the left is the brittle way. See how the code specifically asks for camembert for masked LM? It's hard-coded. It's locked in. So tomorrow, if you want to try a BERT model instead, guess what? You've got to go back and change your code to ask for BERT for mask LM. It's a pain. But now look at the right with the robust auto class. All you have to do is change the model's name. That's it. The code itself doesn't change because it automatically figures out the right architecture. This is how you build flexible, future-proof AI systems.
Okay, so we've talked a lot about the how, but now we need to talk about the should. Because before you use any model, no matter how you load it,
there is one final step, and this one is non-negotiable. It's what really separates the beginners from the pros. And that step is read the model card. Every single model on the hub has one. Think of it as the model's instruction manual, its resume, and its big warning label all rolled into one document. You absolutely have to read it. This isn't just a suggestion, it's a critical part of doing your job right.
So what's actually on this card? All the important stuff. What data was it trained on? That's huge. What was it actually built to do? And maybe most importantly, what are its known limitations? Where's this thing likely to fail or give you weird results? Honestly, using a model without reading its card is like trying to operate heavy machinery without even glancing at the manual. You are just asking for trouble.
And that really leaves us with one final critical question to think about. We have access to these unbelievably powerful tools, and we can get them running with just a couple lines of code. But what are the real-world consequences when we use them without truly understanding their limits? Because that, right there, is the difference between building something amazing and robust and building something that's just waiting to break when you need it the most.